I have a question about, because you've shown about the distribution of the internal forces in particular the bending moments in the shells. What about the displacements? The two shells.
Okay, I leave the floor to Francesco Marmo, who did the analysis.
The analysis, yes. Of course, since the structure is somehow articulated, yet not forming a mechanism, it is more deformable than a classical shell structure. But you can control them and make all deformability constraints, introduce any deformability constraint that you prefer.
There's a question from Maurizio. Thank you, Francesco. And also, this is also an open shell, so it's...
Yes, of course it is very much deformable.
So there's a question from Maurizio Brocato.
Yes, thank you, and thank you for the presentation. It also confirms information that I have and I've obtained on the similar systems. I want to know, what is the measure, the scalar measure of bending you have there? What is this color map?
Maybe Valentina can zoom in. I don't remember the numbers. So this model should be, so this analysis is relevant to a concentrated force of 1 kilonewton at one point of the structure. And we have, so the peak value of stress is 60 Newton per meter over meter.
But I mean, what is this? Is the maximum stress on the skin?
This is the maximum. This is the maximum bending stress.
So what do you call? What is the bending stress?
The bending in shell elements. Shell bending.
I don't know. For me, a stress is not a scalar. So what is the bending stress?
No, this is the maximum value. I mean, the maximum principal value.
Okay, it's the maximum principal value of the stress.
Of the bending.
What do you say bending?
Of the bending, just the bending.
How do you separate the bending stress from other stresses?
So in shell structures, we have membrane stresses, bending stresses, and shear stresses. And we can separate them because these are different components of stresses.
Linear distribution of the stresses in the thickness of the membrane, and you take. And you take.
I take the moment
for a unit. The value on the middle plane, and then you take the maximum of this difference.
Yes.
Okay.
It is. Valentina did explain it because it's quite standard for shell analysis.
Well, I understand, but just to know, it's a scalar, so I have to understand. Thank you.
No, it is just okay. You're right, but it is the maximum principal stress. For the bending tensor.
Okay. Any other question? If not, okay, Sigrid.
Yeah, I'm not fast enough to type in the chat line. A question, Francesco. What about buckling? Because so now it's the shell is more deformable.
Yes, we didn't do any study about buckling.
Yeah,
I expect it is more vulnerable to buckling, but I don't have an answer now.
Sure. But in real life, the sea urchin, I never really see it buckle, right? It's a brittle material. It just kind of
yes, you have seen the let's say the dead animal. Maybe Valentina can say something about the live animal, which has some collagenous ligaments between the plates that allow for relative rotation. And actually, the 3-point bending test was made on a portion of the shell that was taken under salt water. I don't know, Valentina maybe can be more specific.
Yes, we did the experiment on a living organism. So yeah, it was a little bit rude, but we did the analysis in seawater. So in order to don't alterate the mechanical behavior, the mechanical property of the real animals.
Because in like the ones that I sometimes see, like they're usually broken, but I wonder if they are in the water, whether the material is more flexible maybe, and so maybe.
Yeah, in the living organism they are more flexible. The dead one they don't have this flexibility. It's like a rigid and then break like more easily.
Yeah. And so I'm just curious, like, so with the 3D bending test, could you deform it a lot? Like, was it?
Yeah, it was they are a lot deformable.
Yeah, they're here.
While the single plates, it's rigid, so it's not flexible. The suture that are characterized, but these collagen fibers are very flexible.
Oh, yeah.
Yes, but this is due to the collagenal fibers, collagenous fibers.
I would love to see the physical setup, how you did that. Because I'm thinking it's pulling concrete, like crushing concrete and so, but this is a different level of kind of experiment, I think.
Yeah, it was very difficult.
The
but
specimen is very small, of course.
Yeah.
And it's underwater, so yeah.
Yeah.
Great study.
Thank you.
Okay, thank you again.